This resource is the first in a four-part series on factoring polynomials. Part 1 considers the greatest common factor. The GCF is defined. We present a method for factoring the GCF out of a polynomial and provide examples. Part 2 considers factoring a trinomial into a product of two binomials when the coefficient of the x squared term is 1. We present the general process and look at multiple examples. Part 3 considers certain special cases. Those cases are defined, then examples are provided. Part 4 looks at factoring a trinomial into a product of two binomials when the coefficient of the x squared term is not 1. We look at the general process, then multiple examples. The basic idea of factoring is to unmultiply. Factoring is much like playing a game of Jeopardy! You know the answer from a multiplication problem. You determine what the original question was. For example, suppose you wanted to factor the number 12. There are several pairs of numbers that multiply to give an answer of 12. 12 and 1, 6 and 2, or 3 and 4 all multiply to give an answer of 12. A good skill for college-level algebra and beyond is to be able to factor polynomials. Factoring allows us to solve certain types of problems, or just to simplify others. First, let's consider the greatest common factor. One method for factoring polynomials is to find and factor out the greatest common factor. Simply put, the greatest common factor is the largest combination that divides evenly into all the terms of the polynomial. It may have two parts, a numerical part and a variable part. The number part is the largest number that divides evenly into the coefficient for each term. If the coefficients have no common factors, don't forget that 1 is a factor of all numbers. The variable part of the greatest common factor is the largest common power of the variable that all terms share. It is the smallest power of the variable that you actually see. If not all the terms have variables, then there is no variable part of the GCF. Let's look at a couple of examples. Suppose we wanted to find the greatest common factor for the terms of the polynomial 4x to the third plus 12x squared minus 8x. First, we want to find the numerical part. If we look at all the coefficients, the biggest number that divides nicely into 4, 12, and 8 is 4. Now we look for the variable part. Each term has an x, and the smallest power that we actually see is that plain x, which is really x to the first power. Putting the two parts together, we find the GCF to be 4x. Now suppose we want to find the greatest common factor for the terms of the polynomial 9x to the 11th plus 15x to the 8th plus 33x to the 5th. First, we look at the coefficients. The largest common factor for 9, 15, and 33 is 3. For the variable part, again, all the terms have x's, and the smallest power we see is x to the 5th power. So our GCF is 3x to the 5th. But now that we know how to find the greatest common factor, how do we actually factor it out of a polynomial? To factor out the greatest common factor, you must first find the greatest common factor. You then place the GCF in front of an open set of parentheses. You then work term by term. For each term, you divide the coefficient by the numerical part of the GCF. You also need to divide the variable portions. But what really happens is you subtract the power from the GCF. Let's look at a couple of examples. For the first example, suppose you wanted to factor the greatest common factor from the terms of the polynomial 6x to the 4th plus 3x to the 3rd plus 15x squared. First, we need to find the GCF. Using the same techniques we looked at earlier, we find the greatest common factor to be 3x squared. We write the 3x squared and open a parenthesis. Now we start to find what is multiplied by the 3x squared to get the original polynomial of 6x to the fourth plus 3x to the third plus 15x squared. Dividing the numerical part into the first coefficient, we realize 3 divides into 6 2 times. For the variable part, we originally had x to the fourth power, but we divided out x squared. So we removed 2 x's, and we are left with x squared inside the parentheses. Now we can move on to the next term. 3 divides into positive 3, positive 1 time, so we put a plus 1. We had x to the third, but we divided out x squared. We are just left with a plain x, which is the same as x to the first power. Now we move on to the last term. 15 divided by 3 is 5, so we write plus 5. After dividing out the x squared, we have no more x's in the last term, so we are finished. So factoring out the greatest common factor, 6x to the fourth plus 3x to the third plus 15x squared is the same as 3x squared times the quantity, 2x squared plus 1x plus 5. Let's look at another example, just to make sure we understand the process. Now let's factor out the greatest common factor from 24x to the 99th minus 33x to the 70th plus 51x to the 39th. First, we need to find the GCF before we can actually factor it out. Looking at the coefficients, the largest number that divides evenly into 24, 33, and 51 is 3. All the terms have x's, so the variable part is the smallest power we actually see. So the entire greatest common factor is 3x to the 39th power. We put that GCF in front of an open parenthesis. Now we go term by term to complete the factoring. 3 divides into 24 8 times. We had x to the 99th, but we divided out 39 of those powers of x. We are left with x to the 60th power. Now we work on the next term. 3 divides into 33 11 times. It was a minus 33, so we put minus 11. We had x to the 70th power, but after dividing out 39, we are left with 31. On to the last term. 3 divides into 51 17 times, so we write plus 17. We had x to the 39th power, but we divided all the x's out, so we are done, and we can close the parentheses. When we factor the greatest common factor out of 24x to the 99th minus 33x to the 70th plus 51x to the 39th, we have 3x to the 39th times the quantity, 8x to the 60th minus 11x to the 31st plus 17. Factoring is unmultiplying a polynomial. It is determining what you multiply together to get a given answer. We considered factoring out the greatest common factor. It may have numerical and variable parts, depending on the problem. To actually factor, first find the GCF and write it in front of an open parenthesis. Then, term by term, divide the coefficient by the numerical part and subtract away the variable part from the original exponent. But what if there is no greatest common factor? Can you still factor and simplify a trinomial? Stay tuned for part 2 of the series.